Now let's move on. So you might have heard a lot about the word Industry 4.0, which is talking about all the new advancements that are happening and the big revolution that's happening. And let's say the biggest revolution that is really happening when it comes to robots is the fact that right now we are moving away from this type of a solution. The disadvantage of this solution is you need such a huge space because of the safety concerns. And if you want to have a solution where you want an operator to be standing near the cell, then you can't provide it as a solution. So there's limitation where you can use a robotic cell for now. But this cobot, that's a collaborative robot, is making a big revolution in the industry of robots. When I say collaborative robot, it's about having a robot wherein a human can be right next to it. It's about robot and humans working next to each other. So how is it possible? What's happening in it? So the new robots, mostly as of now, it's the smaller size robots. They are being designed in such a way that they are very sensitive. When I say sensitive, if there is an operator and it hits the operator, the robot will stop within a fraction of a second, and it will not even create any force that is going to harm the operator. So once you have such robots which are so safe, where it can be right next to the operator, and even if it hits him, nothing's going to happen to him, there are a lot of customers now who feel safer about the robots. And so they want to use it in a lot more applications than what they were thinking earlier. They are also using it in applications where they need some part of the work to be done by the operator and some part has to be done by the robot. Let's say we talk about an example where instead of this rectangle square box that you see here, you have to tighten and assemble the headlight of a car. So there would be instances wherein probably the operator needs to pick up some of the parts of the headlight, assemble them and put the screws in. And after that, the robot with an automatic screwdriver on top of it can tighten those screws. So some part of the work is done by the operator and some part of the work is done by the robot. So what's the advantage here? You can probably have two of such setups. So the operator would assemble the headlight till he puts the screws in and then jumps to another cell where he does the same thing. When he is working on that, the robot here would tighten those screws. And when he's done there, that robot there would be tightening the screws and he can come back to the station for a new setup. So in this way, you are improving the efficiency and using the robot for the repetitive work and using the operator for the work where there is skill needed. Warehouse automation. This is another thing or the field where a lot of talking is happening. When I say warehouse automation, the big things that come into the mind or where revolution is happening is into the industry of online shopping. You have the big Flipkart, Amazons of the world, where they are people ordering huge number of parts and things, and you need to ship them within few days or even hours. So there are huge warehouses that are coming up almost in every major city of the world, and you are having systems and solutions wherein everything is, most of the work is happening automatically, so that things happen faster and you have lesser possibility of error. So the ASRS, what I have on the top, is talking about what it means is automated storage and retrieval system. So you would have more like a lift that goes up and down, in and out, left and right in the storage area. So if there is some part with a specific barcode number that has to be delivered, this solution would automatically go in, pick it from one of the bins and present it to the front so that it can be packed and shipped to the end customer. It's all automation here that's happening. So that's one of the big things that's happening in the world. The other is AGV, automated guided vehicles. So even we have now a lot of companies which are working into this field, wherein if you have, they would be moving around automatically without an operator sitting on top of it to drive it. So it knows its GPS location, it knows what is around it. It will be picking parts, placing it at the required location without human intervention. So you might have heard about Tesla cars, where everything is running automatically through autopilot. So these machines are more like that, which are on autopilot mode. And in factories, it's already something that is implemented. Whereas in cars on the streets, it is still in the development phase, where it is not a full-fledged solution as now yet. Next, let us talk about Agile, that is adapting to production requirements. So traditionally, the robots have been in a way wherein you would have a robot programmer programming to pick a part and place it at the required destination. So the programmer comes in, does the entire programming for the parts that you want to work on, and it keeps doing the same work again and again. But let's say if you have a new set of parts, then again you need to call the robot programmer, and he needs to redo the new set of programming for the new designs that you have and the new requirements that you have. So you are dependent on the programmer. At the same time, you would probably need a lot of fixtures and tooling to ensure that you have the parts at the right location so that the robot can pick it. But with the advancement in the technology now, it's all easy to program and flexible, and probably even using vision system. So what you see here as an example in this image is that you have a bin filled with simple parts. They are all in a stack in a disorganized way. But since you have a 3D vision on the top, it can recognize using the algorithms of image recognition. It will find out the orientation of each and every part. That information gets passed on to the robot, and the robot can go and pick the part more like a human operator and do the work that it needs to do. So this makes it a lot simple. All you have to do is just bring in the filled bin with the parts, and the robot will take care of on its own. This was not the case earlier. So it's significantly improving the way you do it. At the same time, when you are a manager in the factory, you know that if at all there is a new set of parts because of change in the design, you don't have to call the programmer again. And the robot with its 3D vision can figure it out on its own with probably small, simple offline tweaking of the software. So that brings up a lot of confidence to the factory managers and motivates them to go into automation in the fields and the things that they never were hesitant before. Now let's talk about Internet of Things, IoT. It's about having internet everywhere all the time. I know all of you have smartphones in your hand and you are connected in every way possible to everything. But this was not the case with the machines earlier. And now the machines are moving into that generation where every machine is connected to the internet and everything is connected to the smartphone so that you can access and do a lot of things like remote monitoring, as well as real-time monitoring and remote control. What do I mean by remote monitoring and real-time monitoring? Let's say traditionally in the olden days, or probably a decade back, you would have an operator working in one shift. He would be given a big list in a paper of what parts to be manufactured and how many. So he would be probably told you have to make 50 of these parts using this machine that you have in the front of you in this shift. But at the end of the shift, when he submits his report, he might be showing that there are only 40 parts made. One of the reasons might be that he was probably walking around, probably talking on phone to his girlfriend, or probably the machine was down because of some reason. But the manager never came to know about these things, and he would come to know only when the shift is over and there is nothing he can do to improve it. So with the real-time monitoring and real-time uh, remote monitoring, the manager can know what is happening all the time. So if the machine is down, he can immediately get a beep and he can probably talk to the person in charge and try to resolve it faster so that you don't waste the time. Remote control. I would like to give you an example of what I have actually seen last year. During the COVID time, the company that I work for has a control center in Bengaluru in India. And during the COVID time, when the entire world was in a lockdown, they were able to monitor almost 6,000 robots which are installed all over the world, look at what is happening at them, probably changing the programs to meet the requirements, or even fixing if there is some problem with it. And they could do all these things sitting in the Bangalore, and they were doing this for robots which were running all over the world. So that is all happening now because of the revolution of the Industry 4.0, which is talking about Internet of Things. Probably 10 years back, you could have never imagined this. The person who is in charge would have probably ran, or he would have probably flown in to that country to fix it. So next thing is talking about augmented reality and virtual reality. So what you see here on the image at right bottom is an application wherein, let's say, there is a new machine that you want, and it is still in the design phase. You can probably make use of a tab in terms of the augmented reality. Look at how it would fit into your factory. See and understand if you have some constraints like probably height or the parts near it or the machines around it, and give the feedback to the people who are designing it, which will help in improving things. So that's some of the things that you can do as an example with augmented reality and virtual reality in the factories. Then let's talk about big data analysis and predictive analysis. So what we are talking about here is manufacturing of a lot of things are happening from a long time. Let's talk about probably cars and the automation that's and the manufacturing that are happening in car industry. There are millions of cars that are manufactured every year, and there are probably 1 billion of bolts that are tightened till now. And they are tightened using tools, automatic tools. And its big data analysis, for example, talks about probably making use of all such data that has been there, legacy data, trying to analyze it and see if you can help in predicting what can happen in future. So let's say you have a assembly line of a car. You are using one specific tool to tighten one specific bolt, and you are doing it day in and day out over the years. And using this predictive analysis based on the data in the past, you can probably tell that after 50,000 tightenings, you might start seeing such problem. And probably this is the solution. That is probably an example of predictive analysis. You can't do that without a computer and an analysis of the data by just having an operator, because the data is huge. You make use of softwares to come up with such solutions. Then we talk about digital twin. When you say digital twin, it's talking about having an actual 3D model or the soft copy of whatever you see in the real world. That's a 3D more like a 3D model of everything. Then we talk about the revolution that's happening in 3D printing. When you say 3D printing, it's not just about plastic parts, but even the metal parts which are being manufactured right now on the complex ones. and it is still in the initial phases, but that is also going to create a huge revolution in the future. Now, I would like to tell you a story of Lalita Gupta, where I would like to connect all these dots and help you make some sense out of this screen. So Lalita Gupta has purchased a new house, and she is going to enter this new house with her family, and she's all excited about it. She comes to know from her friend that there is some software and a company that has an online portal wherein she can design her own custom tap that she can use for the house. So she goes online to this website, which provides taps that you use in the house. And she comes across this software that they have, which is very user-friendly. And using that software or the tool, she can design a tap as she wants. So she uses the software, designs a new fancy tap for her kitchen sink with lot of curves and smooth edges, and makes it look really special and unique, so that she is proud of it and she can showcase it to all her friends who would be coming to her house in the future. So she designs it and places an order to that company which makes the taps. So this is a company that makes the taps. So next day morning, the computer of that company, through cloud computing, gets that information that Lalita Gupta has placed an order for a totally custom, unique tap. At the same time, it not just makes the custom taps like what Lalita wants, or probably even what Kunal wants, but also uses predictive analysis to find out what would be the standard taps that will be purchased by people in near future, based on the analysis that it could do, and comes up with a list of parts to be manufactured for the day. And it sends this information to all the machines in the factory. So then an automated guided vehicle picks up the raw materials, the bins, more like what you have seen in one of the previous picture, and presents them to the robots. So the robots, using the 3D vision and making use of the data that it got in terms of the schedule from the computer, starts loading those parts into the machines for making the parts. So it knows and it does everything based on the schedule that is defined by this computer. So part number one is for Lalita Gupta, probably. Part number two is probably for Rajesh Kutarpali. So it defines that schedule and makes everything as it goes on. And now let's come to this 3D printer. So what Lalita wanted was this unique tap where most of the parts are repetitive and the same standard ones, but probably just the front end of it is uniquely customized based on her tastes and requirements. So that part, you don't have to make a programming to make that part. It's that 3D gets loaded into this 3D printer and it makes this part. And when it's done, it presents all these parts to the operator who needs to assemble the tap. And on the screen of the operator, he would see that this tap has to be assembled in this specific way to meet this specific customer's requirement. And he does that. And when it's done, then it's the ASRS turn to pick that and store it in the storage system, so that whenever the truck is ready, it can retrieve that box and give it to the front end to be loaded onto the truck, so that Lalita would get the tap the very next day. So this was an example of a story that can actually happen in future. Now we also talk about some other story or some other instance. You see this machine, I have the same machine here right now. But what we are talking about is a problem that probably this machine would see. there is a motor in this machine which is getting heated up. And since it's connected to the internet, and there is this new technology related to machine learning, the software can predict that this machine will break down and will need maintenance in 5 days. And if it's not done now, in next 5 days, there'll be a huge impact on the production. So this information goes on to the smartphone of the maintenance person who is in that factory. So once he knows that he needs to really go and fix this in next 3-4 days. If not, there'll be a problem. So he goes, when he has time, he wears this fancy, dancy, smart glasses, which is probably using this what augmented reality and virtual reality related tools. So this smart glasses is helping him to go into the machine. It's going to guide him to open up at the problem area and fix the solution. So this is all happening through this dynamic guidance of the software, and he is able to see everything visually using these glasses, and he is able to fix it. He need not really be an expert. It's the computer and the software and these devices that are helping him fix the problem. So now what I have explained you here on this slide were 2 examples, which we wouldn't have thought about probably a decade back. And if you would have told this to someone a decade back, it would be more like a cock and bull story. But this is happening right now, and you can really make this reality in the future because of the revolution that's happening in Industry 4.0. So that ends regarding the basic presentation that I had regarding the advancements that were happening in this field. So now let's talk about the career prospects. So as I had told earlier, and the stress that I was giving to product development, product versus a full-fledged solution. So here we will talk about the career opportunities in product development. That's like probably developing a product like this ASRS or the robot, where you're not thinking about the end customer needs or a specific tailored solution. So in this field, in those companies, you would need a mechanical engineer, electrical engineer, electronics engineer, programmers, and even people from manufacturing domain, because they need to manufacture, assemble, and make these products. So what you are seeing is a wide open requirements of people from all different backgrounds in this field in terms of the career prospects. But the number of companies here are limited, and the number of people they enroll is slightly limited because their design is happening once, and after that they are mass producing the same product again and again. But the engineering time to develop one product is a long, lengthy process, probably like a 2 years thing. Now let's talk about the other phase, integrator or the special purpose machine builders. So this is an industry where there are a lot of companies all over the world. Just for example, within India, there might be at least 100 companies, but they would be smaller in size because, and what they do is a customized solution based on the end customer's need. So let's say there is one factory and they need to automate one specific area. They would call this integrator and say they will need a solution. So that company would go in, analyze what they need, and provide a full-fledged solution that is generally called turnkey solution. When you say turnkey, what it means is you turn the key and press the start button and it starts working. So it's the complete responsibility of the integrator to provide a solution like this or probably like this, where it does the entire work on its own, and the factory people who want this solution need not be an expert in it. It's this company that is the integrator who is an expert in this field. And you would have mechanical engineers, electrical engineers, robot programmers or PLC programmers, and project management team, and SCM means supply chain management, the people who procure the parts and probably assembly, super people in the shop and all those things. The beauty of this field is that you will be working on a new project probably within every 3-4 months, because they are small in size mostly generally, and within 3 to 6 months time frame, it would go from the start till the end. So within 6 months of the start of the project, you would be seeing the actual machine in the customer factory running and doing its work. And when you take up the next project, it would be again for a new customer and new requirement. So you will be jumping from one project to the other, which will be always new and different. That ends my presentation. Thank you everyone for the patience.